Hello, everybody. So tonight starts module 7 of 8. So we are very quickly approaching the end here. We already finished the Python section. So one of the things is this isn't a Python course, this is a software development course. So we're going to look at more than just Python. So we're going to look at a couple other languages this week, things that might be useful for you. And right now, there's not an assignment for the module 7. You may have noticed that there will be by the end. So like in previous modules, there'll basically be 3 small programs to write. The big difference this time is they're not going to be Python programs. I ask you to write them in a certain language. And one of them is going to be in the language tonight. And then one of them will be about to write a macro for Microsoft Word, probably Word and Excel. We'll look at the language that we would write macros in there. I'm thinking that's going to be Wednesday. And then one of the ones that you looked at last week, something in the C family. I'll probably ask for something in Java, because I know people in the game development class in the afternoon saw a little bit of C# and C++ can get a little bit tricky compared to the other ones. Most all of our other programming languages are like cleaned up versions of C++. So it's easy to get lost there. So I'll probably ask you to do something small in Java. That one will probably be something you've done before, and then a macro, and then what I'm thinking is one of the assignments that you did in Python earlier this semester. I'll choose one of those assignments from earlier this semester, and then have you remake that in PowerShell. So another to see the same logic applied in different languages. That's one of the points we're going to look at with this. There are lots of programming languages out there. They all have different strengths and weaknesses. And if you're heading into software development or like anywhere in IT, you might need to know a few of them. Software developers just need to know more than the average IT person, like if you're a networking person or server administrator who's taking this course to get a little bit of Python. There's just a little bit of software development languages that you need to know. The software developers probably need to know quite a few. So one thing I would recommend is have some program that you know really well that you can use to learn a new programming. I use the classic video game Space Invaders. Rows of alien ships coming down, they move back and forth, and then you have a little tank at the bottom and you shoot at them. And as the ships get destroyed, they move faster, and they get lower and move faster. And so they're steadily getting faster and moving lower to the ground. And when one of the ships reaches the ground, the player loses the game, basically. Or if you destroy all the ships, then win the game. I think those people are familiar with that game. It's from the late 70s, a very early video game. But I have programmed that so many times, I don't have to think about the logic at all. That's what I use to learn a new programming language. It covers graphics, which I rank graphics higher than academia does in general. I mentioned that when we were looking at GUIs. I would have started with GUIs on day 1 of the SDEV 120 class. The core people who had me for if I did that, people who had me for the course would not align well with other classes, with other instructors. So I need to try to match things up. But I rank graphics already. So it covers graphics, arrays or list or some sort of collection, variables, some calculations, adjustments, increment, decrement things, and loops, and a whole lot of the basic syntax of the language is included there. So you want to find something like that, a program that you can write really, really well and use that so that you don't have to think about the logic. You know the logic for the program, and all you need to focus on is the syntax of a new language and quickly learn the basics there. And then you can get into the specialized pre-built functions that make up most of the language. So when I say syntax, I mean the basic, a selection structure, and a while loop and a for loop, how to define a function and all those little parts that we use to build up the other stuff. And then once you get that down, then you can jump over and start looking at the pre-built functions and stuff. And tonight's example is going to look at something is we're going to look at one that's really should be really useful for you. But the main thing I'm hoping you'll take away from this is how to approach a new language, because you're not going to sit there in a classroom for every single language you learn. You're going to sit in a classroom for the first couple languages, and after that, you know how to program. So then you know which pieces you'll need. So after the first one or two languages, then you'll be learning in like your own ways. So that's what I want you to look at tonight, but also the one we're going to use for an example is an incredibly useful one, a very nice one to know, and that's Powershell. Did I start the recording? I did record, yes. Okay, so I said I was going to include this in in the assignments. So Powershell, the first note here is that is a modern syntax for an operating system control language. Which we have quite a few of those. Most operating system control languages date back to the 70s. So I'll make a little note here. Most OS control languages date to the 1970s. And programming was very different in the 1970s than it is today. Things evolved quickly, mostly in the 80s. Up to the 1970s, anything to do with computers was still high-end research only sort of thing. Some businesses have started applying it, but even then it wasn't that far. It was in small things. So computers were still pretty small, and we saw so much growth in computers from about 1985 to 1995 when GUIs really took over, and then the growth just shot off exponentially. So things written in the 1970s are very different than anything we do today. I have some notes, but I didn't get around to pulling them out. Hopefully they're going to hear the top. They have the like details on the history, like dates and stuff, because I don't think I remember all the dates off the top of my head. There it is. Okay. So this was the Windows version. Microsoft created this early 2000. Created by Microsoft in early 2000s. And you all know the name Microsoft. Sometimes there's some really aggravating things come out of that company. It doesn't make a lick of sense. But then other times they do abnormally great things. This is one of the abnormally great things they did. This one was so good that others were working on a new operating system. Everybody was working on a modern one because the 1970s stuff was way out of date by then. But when Microsoft finished theirs, Linux and Apple just scrapped their plans. Like, yeah, we're just gonna make PowerShell compatible. So it's not just a Windows thing. Let me share my screen. As soon as the screen share starts. Wait, anyway, there it goes. So if I hit Windows X and then I to open the terminal. So here's PowerShell. This is the one we're going to be working in. It's actually the shell where we input an interpreted language. So it runs one line at a time. which gives us lifetime control of the operating system. And really, anytime we click something on a GUI, it calls a PowerShell instruction in the background. Any place we can click on a picture is just pre-configured to run a PowerShell instruction. Commands still exist, but it hasn't been used since Windows Vista has switched completely to PowerShell. So command is only used legacy. If you input stuff in command prompt, it is translated into PowerShell before it runs. It's only used as legacy because when they try to get rid of it, all kinds of people freaked out. So if you type instructions for command prompt in Windows, the computer will automatically write the PowerShell instruction and run the PowerShell instruction. It's only a legacy thing. But it's Windows. We're going to look at it here on this nice blue win for Windows. On my machine, if I push Control-Shift-4, it boots up a little Kali Linux one. And all versions of Kali Linux, if you type PWSH, it switches from, I had Zeech running originally, you can't really tell that initially, but it'll switch and run with PowerShell here. So all the stuff we're going to look at tonight will work on any Kali Linux machine. Any other Linux machine, sudo apt install PowerShell, and then you have PowerShell to run your Linux machine. On an Apple, again, Linux and Apple, when Microsoft released PowerShell first, they just abandoned their plan. They just cut their plans. So like, forget what we were doing, just make that Microsoft thing compatible. So if you look for PowerShell on a Mac, right at the top of, what was the top result last time? Okay, they changed their URL. It's still the official docs. But right at the top, here's the instruction with a copy button. So you don't even have to go through all the trouble of pushing Control-C. They give you a button to copy and paste. Just hit that copy button and run that command in your Mac terminal, and then you'll have PowerShell on there. It will work for any language, or it will work on any of your operating systems. That's one of the really nice things about it. One of the exceptionally nice things for Mac and Linux. Let me go right here. If I just ask what shell I'm running here, oh, whoops, Echo, I think it's lowercase. Nope. Echo shell, lowercase, yeah. Okay, so I was running a bash shell. It tells what shell's running, but only in text. We saw that in Python. We're programmers, we know how to grab text and parse through it and deal with stuff. PowerShell, the first thing I'm going to mention, if I switch over to PowerShell, if I store that somewhere, I'll store it in a variable called H. We're going to talk about this in more detail later. This is just a preview, actually beyond the scope of what we're going to look at tonight, but this is one of the best things about it. It's called the host here. So if I type the command get host, I stored that to a variable, kind of like that built in when in the bash shell that just says where the fish shell or whichever terminal system we're using. If I use this, call up that variable, you see all these different, there's more than just, there's all the text output. But notice how it's kind of consolidated into different sections. All of those things down the left-hand column, everything is an object. So it doesn't send back text. It sends back an object. Every single thing we have is always an object that can be used in another script. Text is just a supplement. Text is just an extra thing on top of it versus those old operating system control languages. The return was always just text. We had to deal with that. So I can just .h dot what's something that would have brain space. So any of those words, I can ask for this stuff. Oh, I thought that was going to have an array in there, but I don't see any array. Oh, there's only one. If I had several things going, there would be an array of things. We'll see how to access array soon, but and keep that going. That variable where I saved the host information, run space dot state, and access just that one particular thing. Oh, that didn't work. Maybe I do need to do that as an array. Okay, it's not an array. Okay, that returns some text. That other stuff has alternate things in there. But that should look familiar from what we were doing in Python, right? All those dots in the object to access different attributes about it. That's what we always have to work with. So that's the first point in the modern scripting one. And I did that in on Kali instead of the regular one to show that it does run in Linux. All installations of Kali Linux will already have PowerShell. Some of the other versions of Linux, the big ones have it installed. Other ones you just have to type whatever installer you're using, just ask for PowerShell it out. And then when you put it in your like shebang, it's PWSH is the actual command to type in. Same thing for a Mac terminal, created by Microsoft in early 2000s. Other operating systems scrapped their plan. They're similar projects. I guess that's a good word for it. Similar projects. And went PowerShell compatible. So that objects that we just looked at, we're not quite going to get there in tonight's coverage. But that's one of the modern scripting tools. The other one would be the way we put together selection structures and loops are going to look almost identical to how we did it in Python. Versus some of y'all have probably seen that in like a bash scripting course somewhere. Seen bash scripting and the way we did it in the 1970s looks nothing like the if-else structure we put together in Python or the while loops we put together in Python. Look very, very different back there. Yeah, so the early 2000s, they started doing that. It is the instructions to run our Windows system, but it is all like Python is an interpreted language. All of our operating system control language, anything that we're going to call operating system control has to be interpreted. That way we can run a single instruction at a time, which gives us lifetime control. We can, this is lifetime control of our computer. This one will be very useful for you. Earlier in the semester, we looked at what to do when our program was finished. And one of those things was not give the program directly to the user. We in our class example, we went back to the old command prompt instruction, wrote a batch file. And so the command prompt instructions start that instruction, and then that's what we gave the user. That way we can put it in a selection structure to make sure that if we rely on a certain database that's on the internet, we can make sure the Wi-Fi is on before we run the program. Or make sure we have an internet connection before we start our software, because otherwise it's just going to crash. Our software needs to access things on the internet. or pictures to put on the buttons. Right? If the user deletes the pictures, the icons that go on the buttons, then our software is going to crash because we don't have the picture. We don't have the picture of the floppy disk to put on the save button. So we want to check and make sure those things are there. PowerShell would be a good way to do that. We have a modern scripting language. We have a list of things here that we want to do, things that we saw in different languages, and I have a list. I think I'll combine the list instead of writing it on the board first. I'll just go through things and then we'll make sure everything's covered in the list. Kind of discuss that. Since this is operating system control, I'm going to start in a different place. Or well, maybe we'll get there in a minute. I'll start in the normal place. Got some variables. Right? That's the first thing. I'm going to write it on a list here. New language. So whenever I sit down to learn a new programming language, there are 8 things I want to learn ASAP. Things to learn ASAP. To learn as soon as possible. Which that's probably really small since I'm sharing my screen, but so the things we want to learn as soon as possible. And now that he just joined us, let me, okay, your mic's on. So we were looking at PowerShell tonight, Joseph, and that is a modern operating system control language, something Microsoft did a really good job at. They did such a good job that as soon as they released it, both Linux and Apple dropped their plans to make their own modern operating system control language. It started at 6:30 instead of 7:30. And I was going to review this because I know you're on a Mac. So Apple dropped their plans and just went with the one Microsoft made. So if you want to do put that on your Mac, you can just Google PowerShell on a Mac. PowerShell on a Mac. And this first link right here, learn.microsoft.com. That has 2 instructions you need to run. So you'll just hit the copy button here and run that first instruction, which actually you probably don't need to use that unless it's a brand new Mac and you've never installed anything. But it doesn't hurt to run it again. And then the second one, either type in this instruction or copy and paste this into your terminal. And then whenever you open a terminal, if you type PWSH, it will use PowerShell instead of Zeech. So a modern language, one of the points we started with was back in the 1970s, we wrote code very differently. There was a lot of growth in the 80s and 90s and 2010s. And Microsoft, well, there's a lot to complain about with the company. Every once in a while, they do things really nice. PowerShell is one of the best things they've ever done. Like so much so that Apple immediately scrapped their own plans to do something to use what Microsoft made. That should be a clear indication of how great of a job they did on this. But we look at Python, a modern language, so that's what we've seen and what we mostly study. So we go to things like command prompt or Zeech or Bash, all the ones written back in the 1970s. Well, for one, everything was written differently back then. Everything had to be abbreviated. RAM was a very precious commodity, and we certainly didn't want to waste it on computer experts. So everything for the programmer was abbreviated because we didn't want to waste RAM. Our return, we looked at that a moment ago, the returns only came back as text. So then the programmer had to parse through that text and do things and write out, do a whole bunch of work to bring that back into something usable. So those things are a couple of the big things that were addressed. In a modern scripting language, we're no longer restricted on RAM. So we don't have to remember both what it does and how to abbreviate it. Everything is spelled out fully. All the names are spelled out fully, and typing is really easy. And right now we have the blue window open, but before we end tonight, I'll show you a place where we get predictive text and all that nice stuff, where we have a list, and then we just type the first couple letters and choose it from the list. That makes it so much easier. So that one I typed earlier, get host. A host is the window we're looking at. That's where we're typing in the shell where we're actually running. You might remember that word, seen it in, probably seen that in Python stuff as well. We put our Python code in the text file, and then when we hit run, it goes over to the shell and actually runs the program there. Or we can type instructions one line at a time right in the shell. So we have options to do that. But notice everything's spelled out. And there were really, really nice naming patterns. We're definitely not going to look at everything, but usually if we need to retrieve something, we use the word get. So get host. If we want the current working directory, which that's one that was different in a Linux shell, CD means change directory, and it's an instruction to do something. In Windows, CD was current directory, so it prints out. It's actually a variable holding the value. But for PowerShell, there's updates, so that instead of change directory, that would be set location, and it returns that value. Or we get location. If we want to change it, we do set location. If we say get location, it returns the value telling us where we're currently located. Host is the thing, so we can clear -host. And notice how there's some keywords. So there's a couple there, location, host. Those are the things we're dealing with. Where are we at in our computer directory structure? And host refers to the shell. So get host. And then in the middle of the screen there, we kind of see the combinations, getter and setter with location. Or here, we want to do something to the host. We don't want to just retrieve values about it. We want to clear the words there. So clear host. Also in your terminal, the old instructions, they kept them around. So like the old instructions for CLS for clear screen still works. They didn't get rid of anything, they updated it. Or they kept it as an alias. There's different ways. Also the old Linux commands, some Linux commands will also still work. Like I can type ls, which is a Linux command, not a Windows command, and still get the whole directory structure. Which the Windows command would be directory, so the old one still works. But with PowerShell, the modern scripting language, they got rid of all those abbreviations. We spell things out. So the things in this folder, those are all language we use has evolved quite a bit since then as well. So nowadays we would say everything in this folder is a child of that folder. All the files, other folders, all of that, it's a child of the folder. So the proper PowerShell way to do that would be get child item. And I type that in all lowercase letters. It is not case sensitive. So if you look it up, it would probably look like that with Pascal written in Pascal case. But any of the keywords built into PowerShell are not case sensitive. But just like Python, the things you write are case sensitive. So you will need to watch for that. You see we get the same thing there. Get child item, returns all that. And once again, if we stored that somewhere, it would come back as an object, not a big text list. So we can also access all of those independently. Well, let me do that. Clear host, and let's put this in something called, actually, I'll put this in something called a variable called files. And to create a variable, put a $sign first. So that's going to be an important word. I'm going to write this down somewhere. I'm going to stop the screen share and write this word on the board somewhere. I can't find a marker. There we go. PowerShell is what's called a loosely typed language, if I can spell it correctly. Loosely typed. So most of the semester we were working with Python, which was open typed, and as you probably saw from many error messages over the first few weeks of the semester when you were doing your homework, we don't have to say what type of data we have. We just grab a variable and put something in it, but the type still matters. Everybody saw what happens if you try to concatenate an integer to a string. You can only concatenate strings. Probably saw that error message enough times to get frustrated over it and be like, oh, I already knew that. That's open type language. Type matters, but we leave it to the computer to figure out what type of data we have. We also very briefly looked at some C stuff last week where it's just a strictly typed language, and we have to explicitly say we have an integer or we have a string, and we can't ever change that. We say that ahead of time. We have to be strict about what type of data we have. Loosely typed is kind of the extreme the other way. Basically, one way to think about it is there is only one type of data. So we don't ever have to worry about what it is because we only have one data type. We usually call it a resource. And you can spot loosely typed languages because the variables will always start with a $sign. That's the convention. If your variable names start with a $sign, you're in a loosely typed language. So files, and I'll assign that to the value get child item. So it brought that back, but then again, in the 1970s, when we run an instruction, it sends us text back, and all we get is a bunch of text written on the screen. But here, dollar files, there was a bunch of them. So if I put square brackets like we're indexing an array and ask for just the fourth one, and see we're actually, it gave us back an array of file names. And not just all of that. So that dot name. Is there anything I can open? What is the, if I do the whole thing, I'll print this out. Let me change this. So set location. Location is the current working spot where we're currently working at. CD, CD still works. Most people just like that. But when I change the direction, the location to someplace where I can actually have a file we can read and see what's there. Set location to documents/delete. The normal working spot. Oh, we're back to the Linux command. Sorry, that was happening. Let me do this again. So now files are going to be get child item of what's here. So I print that out. We can see several things. Oh, there's a text file. Most.py. .py is Python script. That means it's a text file. So that's something we can read and see some text. So which one is that? That's 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like index 9 in that array should be that file. We get other information about it, the length of it, the last time it was edited, what mode is it, it's set to be appended to, But in particular, there's that name. So dollar file 9 dot name, and we see that's most.py. There's where the text is. But notice how it's an actual object that we're working with. It's not just, it's already stored somewhere ready to be worked with in another script. So if I wanted to run that here, I'd enter the instruction to start the Python interpreter. And then that variable file, the 9th index in there happens to be a Python script. Just confirm that. And instead of typing Python, then file name to get it to run, I can refer to it from that object. So that is something we could build up in the script entirely, even if we had no idea what was in that folder, right? Using selection structures, we can entirely build that up and run that thing. This was just a random thing. Hello, silly little goose. How are you doing today? So this one just finds the most common thing. So O is the most common letter in that sentence. That was just something from earlier today that hasn't been deleted yet. A quick example to use, but notice how we never had to worry about the actual name of that file. Anytime we start working with PowerShell, we don't get text back, we get an actual object that we can work with. And in a loosely typed language, our name for that's going to be resource. Everything is a resource. If we want to do some numbers to do math, so now jumping into the scripting thing, the things we need to know. First thing we want to learn when we approach a new language, stop screen share, number 1 on this list. I started the list and then talk about other stuff, but it's hopefully been in the back of your mind. Number 1 here is probably variables, right? Hopefully that was the first thing you thought of. That's going to be the first thing you want to know in a new language. How do you set the variable? And to do that, it's going to be a dollar sign. Let's say X equals 3. And notice that didn't say dollar sign X equals 3. You get very, very used to typing that dollar sign quick. So this evening, as I'm going through this, I will say X, but remember, it's a loosely typed language, so all variables start with the dollars. I'm just not going to say dollar sign over it. But as you get used to this sort of language, you get used to typing that. So you get so used to typing that you stop paying attention to it. Dollar Y equals 4. That work. And then we should be able to do some math with those, right? What's X plus Y? So ones we would expect, the plus sign, dollar X minus Y, this is a -1, X times Y is 12, X divided by Y gives us floating point division. I was going to show concatenation in a moment. Concatenation is great in loosely typed languages. You will really, really like that. Let's try that thing from Python. Right? Python has integer division 2 slashes. Does that work? Nope, that's not integer division. I'll leave it to you to figure out what integer division is. It's a little more complicated than it needs to be. Actually, when we see functions in a few minutes, it will be easier to make your own integer division than it is to use the built-in integer division. So you can look it up if you want, but when we get to functions in about, well, actually that'll be after the break now. But when we get to functions, it'll be easier to make your own function that just gets a number and then truncates off the fraction part than it is to do integer division. That's just a peculiarity of the language. Modulus is what we would expect. X mod Y is gonna be 3 divided by 4, and we get the remainder. What are we gonna get here? So 3 divided by 4 goes 0 times with a remainder of 3. Okay. Or the other way, y mod x, which would be 4 divided by 3, 3 will go into 4 one time with a remainder of 1. So modulus, all of them are the same as what we saw in Python, except for the integer division, and integer division is not really what it needs to be. So I'm going to skip that. You can look it up if you want. You probably don't do a whole lot of integer division anyway. And we're just doing a quick survey of this, sort of the approach to learning new languages. Okay, that's probably the first thing on that list of learning as quickly as possible. How do we do variables? He just pointed something out. If anybody heard on the microphone, sometimes we'll have strings in those variables, and we might need to concatenate them together. I'm going to include that here. Variables and basic operations. Because that kind of goes together, right? When we say variables, we think about doing math with the stuff in the variable and math. But that's not our only operation. We could have strings in there. Let's make a variable called first and assign it the value hello. And a variable called second and assign it the value world. And we need to concatenate those together. And concatenation in loosely typed languages is one of the easiest things there is, because all we do is put that variable into a string. Like literally, we put the variable into a string. So here is the common message. First space second for testing configurations. I just stuck those variables right in the string. No special characters, no breaking out of the string, no casting, changing data types. Whatever resource you have stored in that variable, just throw it right in the string. And if you read through there, you'll see that the value stored there is automatically concatenated. The sum of x and y. Oh, I guess I need to store this someplace first. We have those stored. So z is, z is x plus y. And then we can just put the string together. The sum of whatever's in x and whatever's stored in y is going to be whatever we got stored into there. So you can see there's no worrying about, those are all integers. You don't have to worry about casting them to the other type. Just concatenate them in a string, just throw your variable right into the string. Concatenation is overloaded, so we can also use the plus sign. Plus x plus and plus y is going to be plus z. So that one might look a little bit more familiar. Some people like to do that just because that's what they're used to. And the big thing is you don't have to worry about any casting. We only have one, there's only one type of data in a loosely typed language, so we don't ever have to worry about what it is. There's some variables. Clear host. I'll spell that out. When we have that convention, we have a keyword thing we're working at, we've seen host and location, kind of saw item. Let me jump up there and just kind of jump out of order and look at different things. Because when we wanted the things listed in the current folder, we said get child item, which kind of indicates everything we have is called an item. So that's something we could look into. Get item, set item. There's different versions of it. But new item is how we would create one. And built right in here is another one, another important keyword that you probably already could have guessed was there, is help. We just like get help. And then the thing we want to get help about. So like get help on how to create a new item. And that help probably doesn't look very helpful just yet. So one of the things I want to do is talk about how to read that help menu. So at first, it's overloaded. There's more than one function that has the same name. And depending on how we pass in parameters, the computer will decide which one to call. They both basically do the same thing. It's just, we haven't really talked about overloading. It'll show up a lot more in your 200 level class. But if we, like in a strictly typed language, if we wanted to make a method that just added two numbers together, it's like add and then set up spots for parameters. But if it's strictly typed language, we have to say what type those parameters are. So we'd have to say they're integers, and pass in two integers. But what if we wanted to add floating point numbers? So to do that, we want to do what's called overloading. We make another method, also the same name, we'll just call it add, and the two parameters there would be floating point numbers. And then maybe a third one where we call it add, and one of the parameters is an integer and another one's a floating point number. And then we can add an integer and a floating point number again. So the parameters are different, so the computer would know which one to run based off how we send the parameters in. So our functions are overloaded like that. There's different parameters we would need. So after the function, you'll see in square brackets, that is the name of a parameter. And on this first one, notice we have square brackets, it says dash add, square brackets close, and then afterwards it says string. So path is file path, and a file path is going to be a string. So in the square brackets, we get our parameter and then the type to fill it. And notice here on this first one, the type is outside of the square brackets. That means that is mandatory. We cannot create a new item without making a file path to it. So that one's mandatory, but on the next one, the next parameter is item type, and that data type is inside of those square brackets. So if the data type is inside of the square brackets, then it's optional. So you can see most of the rest of those are optional. Item type is a string. We can pass in a string and say whether it's a file or a directory. I don't know why they said string. There's only, it's not like we have it. We're either making a folder or we're making a file. It's only two types of items we can put in a folder. The third one's the value. That's what goes into the file. So in a text file, we can make a big long string and write that to the text file. That's what we're getting ready to see because that's one of the things on the list is reading and writing files. And then this third one, the force, we're going to skip that parameter for now. That's getting a little beyond anything we've talked about in this course, but notice how there's no item type with that. Square brackets close. It doesn't say what type of item to put in, and then the very next thing is square brackets, so that's the next parameter. Whenever a parameter does not have an item type, it is a Boolean parameter. So if you want it true, you write the parameter, and to make it false, you leave the parameter off. So by default, Booleans are always false. And if you want to make it true, you just type the parameter name. So if you want to create a new item, give it like some sort of string. myfile.txt, item types the file. The value would be the string hello world. And if you want to force, we're not really going to talk about what that is, you would just type dash force. And that. Credential has to do with security. Notice the thing is PS credentials, so that's is it locked down? Do we have a password? Do we have to have Duo log us in, open up the file so we can write to it? And we have to do two-factor authentication to get to that file, all that sort of stuff. And there's some other ones there. But that's basically, that's how we read these instructions. So that was a big thing. I guess it could go on the list. It wasn't one that I actually had in mind for the list, but one of the things is make sure you know how to read the documentation. If you go to the official help menu, can you make sense of what's on that help menu? That's an important aspect. So now that we have the instructions for that, we can make a new text file here. So it looks like we pass in that command, new item. And it's a shell, a terminal, operating system control languages are pretty much always delimited by spaces. So our parameters go into spaces instead of parentheses and commas like we're used to in like Python. So a new item, we need to give it a name. It's going to go in this current folder. So I don't need to type a whole different path. If we want to put it somewhere else in the computer, we just type the whole file path to it. I'll call it myfile.txt. Then, actually, I want to come back over here. I'm going to be explicit and say that is the path parameter. So the path parameter, and then a space, and then the value to put in that parameter. And then the item type for it, it's going to be a file. And then the value for it is hello world. A grave accent in is your tick mark. Microsoft uses backslash differently, so we can't use that for our escape sequence is the grave accent, which you probably didn't know the actual name of that. Usually we call that the tick mark, the one that points the opposite direction of an apostrophe. Oh, it's on the key with the tilde. Most people know that, next to the one. That backward looking apostrophe. It's called a grave accent. But that's how we do escape sequences. That might be an important thing. Hello world, this is a text file example. I'll close that and I'll just use those parameters. The only one that was required was the path. We just had to say where the new item was being created. And when it does that, we get this message saying there's a file, and if I list all this stuff out, get child item, and see right there is the myfile.txt. So that's another one for our ASAP list. As soon as possible. This isn't necessarily a ranking order. Maybe I should use A. Well, I'm going to stick with numbers instead of A, B's, and C's. But not necessarily a ranking, just counting. So we want to learn all of these things, but in no particular order, really. We want to be able to read and write files. Or you might remember from when we did that lecture in class, our technical term for that would be persistent data. How do we keep our data around for more than the current run of the program? When we get to saving full scripts, right now we're typing in the shell, so how do we keep that data around for more than the current line, than the current instruction as we pass it in one at a time in the shell? Reading and writing files. So new item will create a file, the stuff in the file here, I don't see the name of it. The stuff in the file is called the content of the file. So spelling thing about that file, that text file has some sort of content. I'm doing this in a couple ways. So get content, and then the file name we want to get the content of. We're going to get content of myfile.txt. And we can see the text that was written to that file. So okay, that looks good. But if there's a get content, we'll probably have a set content as well, right? Get and set kind of go together. Get if we want to retrieve the value, set if we want to change that value. Get help, set content. You'll see the same thing. So the path, the value we're writing through, what seems to be missing here? Do you see any parameters there that would indicate we want to append instead of overwrite the file? None of those really look like appending things, do they? I'm just going to skip that part for now and just do overwriting. Y'all can look more stuff up later. What I'm going to ask you to do with PowerShell this week in the assignment's not going to, it'll be basic. We'll see we want to see all the parts we need, some basic parts, and talk about what to do when approaching and learning a new language. We need to set content so we can at least write the stuff to the file. I don't see an append thing, so I could go look it up and dig around. But appending can be easy too, because we just saw how to read what's in that file. So what if we did this? We're gonna make a variable called lines and store that, the results of that get content function, and get content on myfile.txt. So now we have the previous lines. So if we go to set content, we want to set the content on myfile.txt, and the value we want to give it is whatever was already there. So that's the easiest way to append. Just grab what's already there, and then throw it right back in there. The lines that were already there, I'll throw in another line break, and here are some more words. And now if we run that get content again, you can see we got all of that stuff that was already there. We lost the original line break. We would need a loop to put that back in. We'd want to loop through the lines, but I was switching the order I was going through this in. I still haven't picked the best order to go through it in because I want to have it similar to the order we saw earlier, but not like every single lecture. Right? Just kind of see how this order that we're going to do it in is kind of developing naturally. So there's 8 things we want to see, and we've seen 2 of them. So we've seen variables and reading and writing files, the $, and then set content and get content, or how we read and write files, just depending on which way it's going, using that value parameter. What's the next big thing we would look at in programming classes? Everybody's seen at least 2 programming classes now. We have some variables, we can do math, we can set the output. So operators, I was actually thinking I usually include those with the variables. So our basic operators. If we drew this as a flow chart, what we know right now would make one long dash, right? Kind of a very boring flow chart. You might want a way to branch out, make decisions. So selection structures are right up near the top, or at least somewhere on the list of things we want to learn as soon as possible, anytime we look at a new language. So a selection structure, for those who have seen the old ones written back in the 1970s, they look like a mess. They get very, very confusing, even if you do them all the time. If you're constantly doing bash scripting. Here, it's a little bit easier. Let me set a couple numbers. I'll use X and Y again. X is going to be 23. Y is going to be 56. So we have a couple values, and we need to check how those relate to each other. So our keyword is going to be if, and then we need parentheses. And in parentheses, we make that comparison like we're used to. If X, and the thing is, well, we can see it in the prompt. Our angle bracket is already used. It means something very, very specific here. Since it's in our prompt, we can't really use that. Angle brackets also mean bit shifting. We saw that briefly the other day. We don't want to bit shift, so for PowerShell, our comparison is done as an abbreviation. So if we want to know less than, dash LT is less than. So if X is less than Y, and then an opening curly brace, and then here's the true part. Right host. That's the full way to say it. You can also just write right or echo. Some of the old ones still work, but it's actually, we're going to write some words to the host. And the words we want to write to the host is X is smaller. And then a closing curly brace. So we don't have to worry about the indenting thing like Python. We can indent it if we want to. But we have curly braces to say everything that's going to happen when that selection structure is true. Then we have keyword else. Else if we don't need to abbreviate like Python does with elif, where we have to combine those and we can't use two words. We can't have a two-part keyword. So Python has to combine else if into elif. So we can write out both of them. And then do another condition, which builds naturally if I just put an else thing here. So else, and then another opening curly brace, and write host. X was not the smaller value. Notice I'm not using the variable. I actually wanted to type X there. Close that curly brace, and then when I hit enter, it's going to run. So X is 23 versus 56. So X is the smaller one. But if I change that around, say make Y 7, and then I'll just push up to get back to that. Push up twice to get back to that same command. Anytime we're in a terminal, the up arrow always goes back to the history. And that way we can see there the else block run. So there's our selection structure, the if else, and else if builds up naturally. It's two words, so else if, and then put a condition in there. So that shows us how to run selection structures. Still a few more things on the list to look at, but it's probably a good time for a break, right? Because we're not going to get through 5 items in the list very quickly, and we've been at this for over an hour, so does 10 minutes sound good to everybody? This looks like a good stopping point. And having seen an if block, the next thing we're going to look at is loops, obviously. You probably have a pretty solid guess of what a while loop is going to look like, having seen what the if else looks like. That's what's meant by modern scripting. Back in the 1970s, those looked completely different. But most of our modern languages, they look very similar. But we'll see that after a quick break. My clock says 7:39, so we will get back to it at 7:49. And I will see y'all in just a moment. Stop the recording. I think I'll grab a coffee.